I got your doubt. This is your answer.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello everyone. Good afternoon. Hi Rajni. Prajwal. Everybody is on time. Good. You're from Red Hills? Great. So yes, I was a teacher there. I hope you remember me. What's your name? So many are there. Vaishnavi, Sonali, Shivam. So tell me, how are you all doing in this very fine afternoon? Tell me very fast, because we have a very beautiful topic to discuss about. Lot much of questions waiting for us. Before that, tell me, how are you all doing? Very fast and quick, so that we can start with the topic. Great, all good. Okay, so for those who don't know me, okay, so some might be thinking who's this particular person is. For them, myself, Ameer Basit, master teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics. Okay, so as you all know, we are here to prepare ourselves for the upcoming board exam, and we'll be mainly focusing on the previous year question, and we'll be doing it in a chapter wise manner and a quick revision of the chapter. And as some of you might be knowing, we have completed these many topics on these particular dates. Those who have missed, don't worry at all, it is still available in the YouTube. Type my name Ameer and this particular topic, you will be getting the particular session. And not only this, we have completed till 5th of Feb, right? Magnetism and matter. And in today's class, we will be mainly focusing on the chapter electromagnetic induction. As the chapter is so big, we'll be doing 2 sessions. One today and one will be done tomorrow. Okay, I'm so cute. Thank you so much. Whoever it is, I can't get the name from there. Thank you so much, Rajni. So whoever is giving me those kind of compliments, I'm so happy for that. Yes, I remember you, Shivansh. Okay, I remember everyone. So I think we have to start with the classes, right? Are you all ready for the class? Tell me yes or no. Yes or no? Yes. Amazing. Thank you so much, Meg. Okay, let's go with the first question. Let's see. So 2 bar magnets are quickly moved towards a magnetic loop connected across a capacitor C. So you can see a loop over here. It is connected with a capacitor as shown in the figure. Predict the polarity of the capacitor. Okay, so how the capacitor is getting charged? Because of the current that is being produced in the loop. So how the current is being produced inside the loop? Because the flux linked with that loop is getting changed. How? Because you might be knowing that the flux is given by the formula phi is equal to B dot A, right? And if the flux linked with any of the coil changes, you know that a current will be produced or EMF is induced there. Okay, so can you tell me, whenever this is at rest, which means whenever these 2 bar magnets are at rest, will there be a current being produced inside the loop? No, right? Because nothing is changing. If the flux changes, only EMF is produced. So I'll write the formula for EMF also. EMF is equal to minus of d phi by dt. If any of these 2 things changes, what will be produced? EMF will be produced. So whenever the bar magnet is moved, the magnetic field linked with the coil is getting changed and an EMF is produced or a current is being induced. Now we have to use the Lenz's law in order to predict the current. Okay, what is said in Lenz's law? It says that whatever is the current induced in the coil is induced in such a manner as to oppose the cause, right? And what is the cause of production of current? Because of the movement of these 2 magnets towards the coil. So if this cause has to be stopped, okay, something has to repel it, which means here of the in this part of the coil there has to be a I'm sorry for that. Here it has to be south, right? Because south and south will repel, and here it has to be north because north and north will repel. So if this side of the loop has to be forming a south pole and the other side has to be a north, how the current has to be produced or what should be the direction of the current? You can find out by using right hand thumb rule, right? If the thumb is in the direction of the current, the curled fingers will give the direction, give the direction of the magnetic field lines, right? Okay, so the field lines here, it has to be inside. Why? Because in the south pole the field lines come inside and in the north comes outside. So the fingers has to go like this. So what is the direction of the thumb? The thumb is showing this particular direction, right? This particular direction you can see. So this particular direction means current is moving in this direction. If the current moves in this direction, okay, what will be the charge at this plate? On the upper plate it will be positive and on the other plate it will be negative, because the current is flowing in that direction. Yes, understood? All got it? How the polarity is being induced on the capacitor, please say yes or no. Make it fast because we have another questions too. Yes, all good? Once is saying sir again. Okay, so many is having doubts. What is the doubt? Can you type in the doubt as fast as possible? Upper part of the capacitor is positive and lower part is negative. Very good. Okay, great. Okay, Isra Fatima, so you understood, it's a great thing. Okay, so I think I should move on. Don't worry Sonakshi, if you have missed any of the theory, it is recorded. You can still watch it again, okay? So I think it's time for us to move to next question. What does it say? Two spherical bobs are there. Okay, 1 minute. Okay, two spherical bobs, one metallic and the other of glass, of the same size are allowed to fall freely from the same height above the ground. Which of the two would reach easier and why? Okay, so I'm going to draw both the balls over here. Okay, see, so I'm having a metallic bob over here, okay, and I'm having a glass bob over here. Okay, it is of same size, everything. So for the glass, which is a non-conductor of electricity, what will happen? It will be coming down with its own weight mg, right? That is the only force happening on it. But when you consider with this metallic bob, when it is coming down, two forces are there. The first force everyone knows, the first force is what? Mg only, the downward force. The other force that will be acting is, you have to discuss on the basis of this induction. Okay, you know that on the earth or on the surface of the earth there is horizontal magnetic field, right, produced by the earth. Okay, so whenever this metallic field or the magnetic field associated with this metallic bob changes, what will happen? An EMF is induced or a current is being produced in this metallic bob, which is called as eddy current, right? A current is being produced which is called as eddy current. I hope everyone knows. Okay, it will be in the shape of swirling eddies. Okay, so the eddies or the current which is being formed in this inside this bob has a peculiarity. What is a peculiarity? According to Lenz's law, it will always try to oppose the cause of the production of the current. What is the cause of production of the current? The movement of the bob in the downward direction. So in order to oppose that, a force will be produced in the upside direction. A magnetic force will be produced. Okay, why a force has to be produced? Because now there is a current in this metallic tube, a current carrying conductor in an external field obviously will be experiencing a force, formula ILB. I hope you know that. So that is why a force is being experienced on this. So the net force decreases, so the net downward acceleration decreases. Okay, so this will take more amount of time to reach the ground when you compare it with a glass bob. Yes, glass reaches faster and easier. Very good. Understood everyone? Great. Okay, so I think I should move on to the next question. Okay, good. Yes, we are talking about the Earth's magnetic field, right? Okay. So repeating, there is no point, Rajini, right? Because it is already being recorded. So I have the same thing to say. What I have to say is, whenever a metallic or a conductor is moving in the Earth's magnetic field, the magnetic field associated with it changes. So the flux changes. So what will happen? Current is being produced. That current is called as eddy current, right? Okay. Next question. I can't tell in Hindi because so many of you might be knowing. So that I'm from Kerala and I'm not so perfect in Hindi. I can talk in Hindi. थोड़ा थोड़ा मुझे जानता हूँ और है, but उतना तो अच्छा नहीं है मेरा हिंदी. Okay, so that's why you won't understand anything if I talk in Hindi. Okay, good. Next question. Okay, I look into. Okay, I was so busy, Prajwal. I look into it. Okay, fine. So next question. Two identical loops, okay, one of copper and the other of aluminum are rotated. Loop it is we are talking about, with some angular speed in the same magnetic field. Compare the induced EMF and the current produced in both. Okay, so we have what? A loop, sorry, we have two loops. One is made of aluminum and the other is made of copper. Okay, it is rotated with the same angular velocity. Okay, and it is in a same magnetic field also. So they are asking to compare the amount of EMF induced in both and the current that is being produced, right? So for some it will be very easy. Those who feel, listen over here. Okay, so aluminum, and think that there is a magnetic field, a uniform magnetic field toward the positive x-axis. Okay, now when this is a copper and when this copper axis is being, sorry, when this copper coil is being rotated, can you tell me what is actually making, or because of the change of what quantity an EMF is being induced? Who will tell me that? I'll give you a very big chocolate for those who will be telling me that particular. Yes, I'll tell you how to find out the direction. Change in flux. Okay, what particular thing in flux is actually changing? Very good, Akash have already told me it is the angle. Yes, great, because the flux is given by n b dot a is ba cos theta, right? In this particular case, the area of the loop is not changing, b is not changing, it is the theta. What is theta? Theta is the angle between the magnetic field and the area vector. It is constantly getting changed, and it is because of the change of that what is being produced? An EMF is being produced. EMF is equal to minus d phi by dt. Understood? Okay, so let us see what is the EMF produced in both. So that is equal to minus of d by dt of phi is equal to nba theta. I'm writing it as omega t. Okay, omega is the angular velocity. I hope everyone knows that. So cos of omega t, then negative of nba comes outside differential because it is a constant, nothing to do with it. So differential of cos of omega t is minus of sine omega t into omega. So this minus and minus will become plus, right? Okay, so the formula is nba omega sine omega t. This is the value of EMF produced, right? In both the cases, in both the loops, number of turns is the same, magnetic field is the same, area of the loop is same, and the speed with which it is rotated is also same. So what about the EMF? Will it be the same or different? What about the EMF produced in both the loops? Will it be same or will it be different? Who is going to be? Yes, Nandini, it is same. Rajni, I don't know why have you said different, because all the properties are same. So the EMF produced in copper and aluminum is the same. Very good, Aditya, Akash, Rajni, Banu, Shivansh. Okay, now the question is, next question, what about the current produced in both of the coils? Current is equal to EMF divided by R. Okay, so EMF is same in all the things. Now the current produced in both of the coil is dependent upon the resistance of the coil. Can you tell me, among copper and aluminum, which one is having lesser resistance? Whether it is copper or aluminum? Whether it is copper or aluminum, who is going to tell me that? Yes, copper has lesser resistance, so the current produced in the copper coil will be more when you compare it with what? Very good, very good. Okay, so the chat is flooded with answers. I'm so happy. It is copper. Very good. Okay, I can't even get the names because the chat is getting flooded. Okay, Lamborghini is there. Lamborghini Aventador. Okay, Hardik, Samrat, Vaishnavi, Ampo, Shivam. Whoever is telling me the answer, good. So the current will be more in copper as the resistance of copper is lesser when you compare it with that of the aluminum, right? Good, happy everyone? Next question. Yes, we have to go for the next question which is waiting for us. Define self-inductance of a coil. How are you going to define the self-inductance of a coil? It is very simple, right? It is a property of a material by which an EMF is induced in a coil because of the changing magnetic flux produced by the same coil is called as self-inductance, right? Okay. Next part. Show that the magnetic energy required to build up the current I in a coil of self-inductance L is given by half Li square, which means the magnetic energy stored inside what? Stored inside this inductor is how much? We have to prove that as half Li square. How will you prove that? First part that you have to write it. When such a question comes, you have to write the EMF induced in the coil is given by the magnitude of EMF is equal to L into di by dt. Negative I haven't written because it is, I'm talking about the magnitude of EMF. Okay, so during a small amount of time dt, if a current of I is flowing through that, the energy stored at that particular moment of time, small energy stored is equal to EMF into I into dt. I hope you know this because the electrical energy stored inside any material is equal to voltage into current into time, right? I hope everyone knows that. Yes or no? Everyone knows that? Potential into current into time, right? Yes, very good. So potential, now I am going to substitute. What is it? L into di by dt into I into dt. What will happen to dt's? It will cancel. So the small energy is equal to how much? L I into di. And if you want to find out the total energy stored inside the inductor, integrate it. Okay, what has to be integrated? Current. Okay, the current initially will be 0 till it reaches a value of I, right? Okay, so L is a constant, it comes outside. I di, if you integrate it, it is I square by 2. Proved? Yes or no? Very simple, right Rajni? Understood? Vanshit? Super good, happy? Yes. Okay. Okay, I took your name, Procuber. Okay, how can that be a name? Yes, good, very simple, right? Great. Next question. Okay, the question is over here waiting for us. A metallic rod L is rotated with angular frequency omega with one end hinged at the center and the other end at the circumference of a circular metallic ring of radius L about an axis passing through a center and perpendicular to the plane of the ring. A constant and a uniform magnetic field B parallel to the x-axis is present everywhere. Deduce the expression for the EMF between the ring center and the metallic ring. Okay, so those who haven't understood what is the configuration, look over here. So you are having a rod. Okay, one end of the rod is hinged at the center and the other end is connected to a circular ring, and the length of the ring is given as L, right? Okay, now what is happening? There is a magnetic field which is inside the particular plane, or it is along the axis, because this is the axis of this particular plane, right? It is about this is getting rotated, or the rod or the circular ring, entire thing is getting rotated. Yes or no? Understood till here? Okay, everyone, I hope understood. Then what is the angle between the area vector and the magnetic field? Who will tell me that? Okay, somebody is already telling me the answer, b omega L square by 2. So here we have to solve it. Yes, the angle between them is 0 only, because this is the area, right? This is the area of the loop. It is projected outside, and what the magnetic field is also inside, right? So you can take it as 0 or 180, but the magnitude is going to be remaining as constant, which is cos of 0 or cos of 180's magnitude is 1 only. Yes, understood till here? Okay, now can you tell me, whenever this thing is being rotated, what is actually changing? whenever this particular rod which is connected to the ring, when it is rotated about this perpendicular axis, what is being changing, or what in the calculation of flux is changing in order to produce an EMF. Okay, so I think for some it is getting confused. Don't worry, I'll write it over here. So the formula for flux is equal to B dot A, right? So BA cos 0, it is 1. Okay, so I'm writing it as B only. Now the EMF magnitude is equal to, magnitude of EMF is equal to d by dt of phi, but the magnetic field is remaining as a constant, so it comes outside, so it is d by dt of A, which means it is the area covered by this rod is changing, and it is because of that particular reason a EMF is being induced. Yes, very good Aditya, Rajni. I'm so happy that you're understanding, right? Okay, now in this particular figure, think that I'm taking a small amount of time dt. Within this dt, initially if the rod was here, think that it is covering a small angle of theta over here within the time within the time of dt, the angle this rod covers is given as theta. Good, happy? Okay, now you have to find out the area swept by this radius vector, so that I can substitute for this dA, which is happening during a small interval of dt. Okay, now how will you calculate this area over here? How will you calculate? This is a triangular part, right? So this part is of r, right? This is having a radius of r, and if this is theta and this is radius, how much will be this arc length? R theta. I hope you might have studied this in 10th standard, right? Yes, very good. So the area of a triangle is equal to half into base. What is base? R theta into height of the triangle. It is r. Now I hope nobody is having a doubt. That is half r square theta. Now b into d by dt of A, I am substituting it as half into r square theta. So what is going to be coming outside the differential? Whatever is constant. R and theta by 2 is coming outside, so I'm writing it over here. So it is b r by 2, sorry, b r square by 2, I'm sorry, r square. Look, r and r is having r square, and what is differential? D theta by dt. What is d theta by dt? What is d theta by dt? Omega. So the formula is half b r square omega. Understood? Very simple, right? It's not so hard, I hope. Very good. So many are telling me the answer. Prajwal, Aditya, Vaishnavi. Good. Happy with the explanation. Got the entire content, everyone. Understood how to solve this particular question and derive this particular formula. Yes, very easy. Very good. So let's go for the next question. What is waiting for us? Okay. So as I want to tell you, the current session what is going on is electromagnetic induction, and the next session is with Ameer Sir, where you can learn about haloalkenes and alloarenes. So after my class, don't go out. At 2 o'clock exactly his class will be starting, right? Okay, so let's move with the next question. Are you all ready for the next question? So Tantra Gautam. Okay, so let's go with the Ameer Sir, the great teacher. Thank you so much. Draw a label diagram of AC generator. Okay, so what is an AC generator? What does it do? It produces AC current, right? Okay, how does it produces AC current? By changing the flux associated with the coil, right? So how will you draw a label diagram? So this is the coil which is connected to a shaft in between a constant value of magnetic field. So the area of the loop, what you can see over here, is a constant, and the magnetic field in between the loop is also a constant. And what is actually making a change of flux to produce a current in this loop? What is happening? It is being rotated, right? Yes or no? So this particular loop is getting rotated. When this gets rotated, what is actually changing? The angle between, look, this is magnetic field and this is the area vector. The angle between them is changing. Yes or no? Very good. So how will you write a formula for the EMF induced? I'm going to write it over here. So look, the EMF induced is equal to magnitude I am writing, or let us talk about not magnitude, it is minus of d by dt of phi, right? Flux. So that is minus of d by dt of What is the formula for the flux? What is the formula for the flux? Number of turns of the coil, B A cos theta, where theta I'm going to write it as omega into T. I hope nobody is having a problem with that, right? Okay, so what all are constant? Number of turns is a constant. Magnetic field, as I have told you, it is a uniform. It's also a constant. Area of the loop is also a constant. Everything comes outside the loop minus of NBA. Differential of cos omega t is minus sin omega t into omega, right? So omega into sin omega t with negative, so the entire thing will become positive. Yes, understood? Happy? Simple as that. So that was the first question. Derive the expression for the instantaneous value of the EMF. We have derived that. Yes, all good, happy. Then there is a second part for the question, where if you do this particular question also, you're getting 5 marks in your board exam. So how many of you are thrilled? Someone is asking, what is your mother tongue? I'm from Kerala, so my mother tongue will obviously be Malayalam. Okay, so the next part of the question, a circular coil of cross-sectional area 200 centimeters square and 20 turn is rotated about the vertical diameter with angular speed of 50 radian per second in a uniform magnetic field of 3 into 10 power minus 2 Tesla. Calculate the maximum value of the current in the coil. The same kind of formula we can use, right? So in a uniform magnetic field where the area of the loop is constant, it is rotated like this, right? So what is actually changing? The angle between them is being changed. So if the angle or is the change of angle is actually producing the EMF in the coil, which formula you have to use? NBA omega sin omega t, right? And if they are asking for the maximum value of EMF, it will be when the sine is having the maximum value, right? What is the maximum value of sine? 1. So the EMF induced is equal to NBA omega. It is not the EMF induced, it is the maximum value of EMF induced, right? Now what is remaining? Nothing. Just you have to put down the values whatever it is given in the question. What is given? Number of turns 20. Magnetic field 3 into 10 power minus 2. Area 200 centimeters square, 200 into 10 power minus 4 for the conversion into meter square. Yes, then omega, what is given? Omega, where is omega? Angular speed 50 radian. 50. Any doubt? Anyone? No, right? Simple. Just do the calculation. How much you will be getting? You will be getting as 0.6 volt. Okay, please bring Mendy. this session is only for board exams, right? So we will be discussing mainly the concept and the previous year question. So we are not doing Mendy quiz over here. Okay, so understood till here? I will bring whenever a session comes like this with the Mendy quiz. I'll surely bring. Okay, great. Yes, it's a 0.6 volt. So the answer for that, once you start multiplying and simplify that, you will be getting the answer as 0.6 volt. Yes, Nehama, because the session has to start like this with the Mendy quiz. All of a sudden from magic I can't bring the Mendy quiz, right? So everything should have a technical aspect also. So I'm just coming and delivering the things. If the Mendy quiz has to happen, so many technical person has to be there, technical things has to happen. Sure, I'll do one class with the Mendy quiz. Don't worry at all. Okay, so let's not waste our time because so many questions are waiting for us. Let us go with the next question. What does it say? What does it say? Figure shows a rectangular loop conducting PQRS in which arm PQ is free to move. Arm PQ means this. Okay, this one, okay, this is able to move. A uniform magnetic field acts in the direction perpendicular to the plane of the loop. So you can see a magnetic field is acting there. Then arm PQ is moved with a velocity v towards the arm RS, which means it is moved in this direction, as you can see, towards left side. Assuming that the arm QR, RS and SP have negligible resistance, all these have negligible resistance, then what is given? Moving arm PQ has a resistance, this only has a resistance of R. Obtain the expression. So we have to obtain the expression for three different things starting from the current in the loop. The first thing what I have to find out is the current in the loop. If I want to find out the current, I is equal to V by R. We have to find out the voltage or the EMF produced inside the loop. So how the voltage is being produced, can you tell me? You know that this is a loop, right? Okay, where this arm can be changed. Whenever you move this particular loop, what is happening? It comes closer, right? When it is coming closer, what is happening? The area is changing. So it is a change in area which is actually producing a change in flux, and that change in flux is actually producing a what? That change in flux is actually producing the EMF in this loop, right? Okay, very good. So here I am marking the length of this as L. Okay, length I am marking it as L, and this for the time being I am calling it as X. Okay, this particular distance, as we are moving it towards our left hand side, this X keeps on decreasing, right? Okay, so I hope you understood till here. So I know that so many knows the equation, it is BLV divided by R, but they are asking for us to derive it. Okay, now the phi will be equal to B into A, right? So B is a constant and the area is how much? L into X. Then EMF magnitude is equal to d by dt of phi. Phi is equal to B into L into X, right? So B is a constant, L is a constant. What happened? Yes, what happened? Okay, it's what I can write is EMF is equal to 1 minute. Give me a minute, guys. I'm sorry. Okay. So what I have to tell you is EMF is equal to d by dt of phi, where we are talking about the magnitude. So d by dt of phi is equal to B into A. So that is again d by dt of B into area is how much? That is L into X. What is actually changing, which is the variable in this particular case? It is X, right? Which means B and L are constant. It comes outside. The what is remaining is d by dt of X, right? So what is dx by dt? Who will tell me what is dx by dt? What is dx by dt? Tell me fast, guys. What is dx by dt? Very good, it is velocity. So I am marking it as BLV. So the EMF is equal to BLV. So what is the value for current? Current is equal to EMF divided by resistance. So that is BLV divided by the resistance is given as small r. So we have got the answer for the first question. What is it? BLV divided by R. I hope nobody is having a doubt on that. Next question. Yes or no? The question came in my pre-board. Okay, very good. So I hope you have understood how to do this particular question. Pulling outside also, what happens is direction only changes. The direction of the current produced will only be changing. Okay, the magnitude of EMF will always be the same. So that's why I have put magnitude sign over here for the EMF. Understood? I hope you know how will you find out the current. How will you find out the current? Right hand, Fleming's right hand rule, right? I hope everyone knows that. Okay. So you got it as such. So this is the formula for the current. Next is the force. From where the force is coming? From where the force is coming? The force is coming from a current is now being produced inside this particular rod, right? How much is the value? BLV by R. A current carrying conductor is now moving with a velocity of V. If a current carrying conductor is moving in a magnetic field, a force is being produced. What is the value for the force produced? Force F is equal to I L into B. L cross B it is. Both are perpendicular. Sin 90 is equal to 1. Yes or no? So the current is force is equal to I into L into B. I am going to substitute over here. What is the value of I? B L V by R into L into B. So this will become B square L square V divided by R. Yes or no? Simple. We got the force again. Next question is the power required. How will you find out the power? Power is equal to force into velocity, right? Yes or no? Power is equal to force into velocity. So power is equal to force into velocity. So force is equal to b square L square V by R into velocity will make V square, right? So the net value of power is equal to b square L square V square by R. Understood? Everyone? Happy? Guys, tell me. Got it? I hope no one is having doubt. I hope you are happy with the session. Fail hoga apu, no one will fail, okay? Trust yourself. At least you have to trust yourself, right? Okay, so trust yourself, do whatever it is possible, study the maximum you can and give the best in the exam instead of getting tensed or making yourself pressurized. Okay, go for the exam, just write it, come down. Don't think that this is the end of the world, as I say in all my sessions. Okay, so be happy, chill, go and write it, give the best, yaar. Okay, fine, pakka. Best book for the board exam, NCERT is the only book. NCERT exercise, which means NCERT theories, NCERT exercises, previous year questions, nothing more, nothing less, if you want to get full marks for the CBSE board exam in physics. Okay, very good. So I know that so many will be having doubt and how to proceed, how to make a proper schedule. So Vedantu is there to help you guys in order to make a customized plan, to give a proper analysis of the previous year questions, in order to clear all your doubts, in order to have access to all the recorded videos, so that you can, if you want all these things, come and join the class 12 crash course. And what you have to do, go to this particular link and apply this magical code. Do you know why it is magical? Because this magical code, if you apply, instead of paying 12,000 rupees for the course, this will be turned into 3,799. So the magic will be created by this particular code. So use this magical code, get this course just for 3,799 and make your life super happy. Okay, my name is Ameer. Someone doesn't know my name also, but it's fine. Adiboli class, thank you so much. Derivatives will be coming about 20 marks. You can expect about 20 marks for the derivations. Thank you so much for everyone. So what you can see over here is a result that is being produced by Vedantu. This is for 2019 JEE Advanced. This is what has happened in 2000 JEE Main, which happened months ago. And I hope you can see the numbers. If you feel like you also want to be a part of this, where your photo also want to come like this, come and join Vedantu and make your life super awesome and rocking. So guys, I hope you have understood my class, and I hope you feel like it is good. So what you have to do, just move your cursor. Okay, you can see a like button, and if you think that this was helpful, share it with your friends, and don't forget to do this. The subscription for all thing what we are doing, we are only asking for a small favor from you. Okay, just to hit the subscribe button. If you hit the subscribe button, not only we are getting benefited, you also will get benefited by all the videos that is coming in this particular channel. You will get the notification, and super awesome classes by super awesome teachers will be happening at all the time. Okay, so don't ever forget to hit the subscribe button. Okay, I hope you won't forget. So I think it's time for me to say bye for this particular time. So till we meet next time, take care everyone, and see you. Love you all.